talk about the addition law of probability and mutually exclusive events. So we observe that if two events A and B cannot occur at the same time, in other words, the events are mutually exclusive or disjoint, then P of A or B or P of A union B is equals to P of A plus P of B. On the other hand, if two events A and C can occur at the same time, i.e., the events are not mutually exclusive, or in other words, they are not disjoint, then P of A or C or P of A union C does not equals to P of A plus P of C. So the addition law of probability states that if A and B are mutually exclusive events or disjoint events, then the probability of A union B or probability of A or B is equals to probability of A plus probability of B. Now we have the question 1 of exercise 2b. The 11 cards numbered 11, 12, 13, 14 up to 21 are placed in a box and a card is removed at random from the box. Find the probability that the number on the card is, in the part 1, even. Write down the sample space in our case. So here the sample space S is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So in the part 1, we have to find out that the number is even. So for this, first we have to highlight the numbers that are even. So here we have 12, 14, 16, 18, and 20. So the number of favorable outcomes, we have 5, and the total number of outcomes already given in the question is 11. So the probability that the number is even is equals to 5 over 11. Now in the part 2, we have to find out the probability that the number is prime. So for this, we have to highlight the numbers that are prime, and those are 11, 13, 17, and 19. So the number of favorable outcomes in part 2 is 4, and the total number of outcomes is 11. So the probability that the number is prime is equals to 4 over 11. Now in the part 3, we have to find out that the probability of number is either even or prime. So here we will apply the addition law of probability. So we will add up the probabilities of part 1 and 2, and those are 5 over 11 plus 4 over 11 respectively, and after adding up we will get 5 plus 4 over 11 will gives us 9 over 11. So the probability that the number is either even or prime is equals to 9 over 11. Now the part 4, we have to find out the probability that the number is neither even nor prime. So to find out this probability, we just simply take away the probability of the number is either even or prime. From 1. So we will take away the 9 over 11 from 1 And here we have 11 minus 9 over 11, and it will gives us 2 over 11. So the probability that number is neither even nor prime will be equals to 2 over 11. Now in the question 2 we have a bag contains 7 red marbles, 5 green marbles, and 3 blue marbles. A marble is selected at random from the bag. Find the probability of selecting in the part 1 a red marble. Part 1, we have to find out that a marble is red. So the probability of red will be equals to number of favorable outcomes is 7, just because it is given that there are 7 red marbles, and the total number of marbles will be 7 add 5 add 3, so it will be equals to 15. So the probability that a marble is red will be equals to 7 over 15. 2, we have to find out that the marble is green, so the number of green marbles is 5 and the total number of marbles is 15. And after simplifying, it will give us 1 over 3. So the probability that a marble is green will be equals to 1 over 3. Now on the part 3, we have to find out that marble is either a red or a green. So for this, we will apply the addition law of probability, just because these two events, that marble is red or marble is green, are mutually exclusive. So we will apply the addition law of probability here. So we will add up the probability of the red marble and the green marble. And we will get 7 add 5 over 15. And after adding 7 and 5, we will get 12 over 15. And it will be simplified to 4 over 5. So the probability that marble is either a green or a red will be equals to 4 over 5. Part 4, we have to find out that the probability of neither red nor green. So for this, we will subtract the probability of either red or green from 1. So from the part 3, we have find out the probability of either red or green. That was equals to 4 over 5. So 1 minus 4 over 5 will be equals to 5 minus 4 over 5. And it will be equals to 1 over 5. So the probability of neither red nor green is equals to 1 over 5. In the question 3, the probability of a football team winning any match is 7 over 10. And the probability of them losing any match is 2 over 5. So what is the probability that the team in the part 1 wins or loses a match? So for this, in the part 1, so the probability that the team wins or loses a match will be a mutually exclusive. So here we will apply the addition law of probability. And since the probability of winning and losing already given in the question, so the probability of winning any team is 7 over 10, and the of losing any team is 2 over 15. Now, here we will take the LCM, 10 and 15. 2 times 5 is 10, and here the 15. Now here we have 3. Here we have 5. 3 5s, 15. Now here we have 5. And here we have Now here we have 2 times 3 times 5, and it will be equals to 30. So the LCM is here 30. 7 multiply 10 times 3 is equals to 30. So here we have 3. 15 times 2 is 30. So here we have 2 times 2. Now 7 times 3 is 21, and 2 times 2 is equals to 4. And here we have over 30. 21 add 4 is 25 over 30. And after simplification, it will give us 5 over 6. So here we have the probability that the teams wins or loses a match is equals to 5 over 6.
Now in the part 2, we have to find out the probability that the team neither wins nor loses a match.
Now we have to subtract the probability team either wins or loses a match from 1. Now the probability of team either wins or loses a match was 5 over 6. So 1 minus 5 over 6 will be equals to 6 minus 5 over 6. And it will be equals to 1 over 6. So the probability of neither wins nor loses a match will be equals to 1 over. Now in the question 4, the probability of 3 teams A, B, and C winning a basketball competition are 1 over 14, 2 over 7, and 3 over 7 respectively. Only one team can win the competition. Calculate the probability that in the part 1, C does not win. On the part 1, to find out the probability that C does not win, we simply subtract the probability of C wins from 1. And the probability of team C wins is already given in the question, and that is 3 over 7. So we will just simply take away 3 over 7 from 1, and that will be equals to 7 minus 3 over 7, and that will becomes 4 over 7. So the probability that C does not win will be equals to 4 over 7. Now, in the part 2, we have to find out the probability either A or B wins. So for this, we will apply the addition law of probability just because the events of winning of team A and or winning of team B are mutually exclusive. So we will add up the probabilities of the winning of team A or team B. So those are 1 over 14 plus 2 over 7. Now to solve these fractions, we will take the LCM of 7 and 14. So here we have 2. 2 times 7 is 14. And 7 times 1 is 1. So 7 2 is a 14. 7 2 is a 14. So 14 times 1 is 1. So 1 times 1 plus 7 times 2 is 14. So here we have 2 times 2. Now 1 times 1 add 2 times 2 is 4 divided by 14. So here we have 5 over 14. So the probability either A or B win is equals to 5 over 3. We have to find out the probability of none of these 3 teams win. So we can find out this by simply subtracting the probability of either one of these 3 teams win from 1. So here we have 1 minus the probability of the teams A, B, and C are given respectively in the question, and that those are 1 over 14 plus 2 over 7 plus 3 over 7. LCM of 14 and 7, we will get 14. Now 14 times 1 is 1, so 1 times 1 add 7 times 2 is 14, so we have 2 times 2. Again, 7 times 2 is 14, so we have 3 times 2. Now here we have 1 minus 1 add 4 add 6 over 14. And after adding up, we will get 1 minus 6 add 4 is 10 and add 1 is 11. So 11 over 14. And now we have 14 minus 11 over 14. And after simplifying, we will get 3 over 14. So the probability that none of these three teams win is equals to 3 over 14. Now in the question 25, every year only one student can win the Students of the Year award. The probabilities of Wasi, Wasim and Nadia winning the award are 1 over 3, 1 over 8 and 1 over 20 respectively. What is the probability that one of them will win the award, none of them will win the award, Wasi and Wasim will not win the award? Now, in the part 1, we have to find the probability that one of them will not win the award. So, the probability of either one will win will be equals to, by adding the given probabilities of winning of Wasi, Wasim and Nadia respectively, and those are 1 over 3 plus 1 over 8 plus 1 over 20. Now we will take the LCM of the numbers 3, 8, and 20. So we will start with 3. 3 ones are 3 is 3. Now we have 8 and 20 as it is. Now 2, 4s are 8 is 8. 2 tens 20. Now we again take the number 2. 2 twos are 4 and 2 fives are 10. Now we have 2. 2 ones are 2 and we have 5 now. Now we have 5 ones of 5. So now we will multiply all these numbers. 3 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5, and it will be equals to 120. So the LCM of these three numbers is 120. And now by using the butterfly rule, 3 40s are 340. 3 times 40 is equals to 120. So here we have 1 multiplied by 40 plus now as we have taken the LCM and that is 120, now we will use the butterfly rule here. So 3 times 40 is 120. So here we have 1 times 40 plus 8 times 15 is 120. So here we have 1 and 20 times 6 is 120. So here we have 1 multiplied by 6. So 40 add 6 divided by 120, and it will be equals to 61 over 120. So the probability that either one will win will be equal. Now in the part 2, we have to find out that what is the probability that none of them will win the award. So the probability that none of them will win the award will be equals to 1 minus will win. Since in the part 1, we have find out the probability of either one will win, and that was equals to 61 over 120. And now we have 120 minus 61 over 120. And after subtracting, it will give us 59 over 120. So the probability that none of them will win will be equals to 59 over 120. Now in the part 3, we have to find out what is the probability that Wasi and Wasim will not win the award. For this, we have to subtract the wins from 1. So for this, we will add up the given probabilities of Wasim and Wasi's winning in the question. And that was 1 over 3 plus 1 over 8. Now we will take the LCM. Of 3 and 8. So here we have 3 ones are 3, and here we have 8. So 2 fours are 8, and 2 twos are 4. And 2 ones are 2. Now after multiplying, 3 multiplied by 2, multiplied by 2, multiplied by 2. We have 24. So the LCM is 24 by using butterfly rule. 3 times 8 is 1 multiplied by 8. Add 8 times 3 is 24. So minus 8 times 1 is 8. Add 3 times 1 is 3 divided by 24. Now we have 1 minus 11 over 24. And it will be equals to 24 minus 11 over 24. And after subtracting, we will get 13 over 24. So the probability that Wasi and Wasim will not win will be equals to 13 over 24. Now in the question 6, the letters of word mutually and the word exclusive are written on individual cards, and the cards are then put into a box. A card is picked at random. What is the probability that the letter on the card is in the part 1 a U, in the part 2 N E, in the part 3 a U or NE, in the part 4 a consonant, in the part 5 a U or a consonant, and in the part 6 a U or a vowel? So in the part 1, we have to find out the probability that the letter on the card is U. So first we have to count the number of U's in the box. So the number of U in the box will be equals to, so in the word mutually, we have 2 U's, and in the word exclusive, we have 1 U. So in total, we have 3 U's. So the number of U's in the box will be equals to 3. And now we will add up the total letters in both the words. So in the word mutually, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 words. And in the word exclusive, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, we have 17 words. So the probability the card is a U will be equals to 3 over 17. Now, in the part 2, the probability that the letter on the card is an E. So first we have to find out the number of E in the box. So in both the boxes, we will see the number of U's. So in the word mutually, we have no E, and in the word exclusive, we have 2 E's. So the number of E in the box will be equals to 2. And now the probability that the word on the card is in the letter E, and that will be equals to 2 over the total number of letters in the box, and that is 17. So the probability that the letter on the card is an E will be equals to 2 over 17. Now in the part 3, we have to find out what is the probability that the letter on the card is A or N, is U or an E. So for this, probability of A or an E will be equals to, since OR means union, and the probability of U and an E are mutually exclusive events. So here we can apply the additive law of probability. So the probability of AU plus probability of an E. And since we have find out these two probabilities in the part 1 and 2, and that was 3 over 17 plus 2 over 17. And now we will add up 3 and 2. So here we have 3 plus 2 over 17, and after adding up, it will be equals to 5 over 17. So the probability that a letter on a card is A or an E, is a U or an E, will be equals to 5 over 17. Now in the part 4, we have to find out what is the probability that the letter on the card is a consonant. So first we have to find out the number of consonants in the box. So first we will count the number of consonants in both the words, mutually and exclusive. So in the word mutually, we have 1, 2, and 3 vowels, and 1, 2, 3, 4, 5 consonants in the word mutually. And in the word exclusive, we have 1, 2, 3, 4, and 5. And 5 consonants in the word exclusive. So in total, we have 10. So the number of consonants in the box will be equals to 10. Now the probability that the letter is a consonant will be equals to 10 over total number of letters in the box, and that is 17. So the probability that the letter on a card is a consonant will be equals to 10 over 17. Now in the part 5, we have to find out the probability that the letter on the card is a consonant or a U. So for this, since we can see that these two events, that a letter on a card, a U or a consonant, are mutually exclusive, so here we will apply the additive law of probabilities. So here we will add the probability of a U plus the probability that a letter is a consonant. Since we have already found out these two probabilities, and those are 3 over 17 plus 10 over 17 respectively. Now we will add these two fractions. So here we have 3 plus 10 over 17. And after adding up, we will get 13 over 17. So the probability that the letter on the card is a U or a consonant will be equals to 13 over 17. Now in the part 6, we have to find out the probability that the letter on the card is a U or a vowel. So first, we have to count the number of U and vowels in a box. So first we will see the number of U's and vowels in both the words. So here we have 1, 2, 3. 3 vowels in word mutually, and 1, 2, 3, and 4. 4 vowels in the word exclusive. But we have to find out the number of U's and the vowels in a box. So in the word mutual, we have 2 U's, and in the word exclusive, we have 3 U's. So the number of U's is 3. Now the number of vowels. So in the word mutually, we have one vowel, that is A. And in the word exclusive, we have one vowel and two vowel and three vowels. And we have four vowels in the word exclusive. So 3 plus 4 is equals to 7. Now the probability that the letter on the card is a U or a vowel will be equals to 7 over total number of letters in the box, and that is 17. So the probability that a letter on a card is a U or a vowel is equals to 7 over 70.